All right, guys, hope everyone's doing okay. We're going to continue learning about differentiation. And just so you see up here, that definition is, when I say the word differentiation, I'm referring to the process of finding the derivative. So far, we've learned two methods. The formal definition of a derivative, which no one's a fan of, but we definitely need to know because it's very complicated. And then we learned the power rule, which I've received almost everyone's homework, and everyone seems to be on track. Again, I will be setting up a Google Meet for later this week, but I think I'm going to postpone it to Wednesday or Thursday, depending how much we cover, so that I could get everybody's questions in. Anyway, those are the two forms that you know as of today. And as I said before, there's 4 different methods. So I just want to look at this problem here, which it says y equals 4x cubed. I want to talk to you a little bit about the notation. I know that I've said that if you have y, it just automatically turns into dy dx when we're taking the derivative. But I want to explain why, which will be very helpful in today's lesson on what we're going to learn, the chain rule. Here, y equals 4x cubed. If I take the derivative, what's happening here is the exponent on the y is actually 1, correct? So doing the power rule, if I take that 1 and bring it in front, I get 1, and then this turns into y to the 0. Now, when we take the derivative of any variable, we finish by saying the derivative of that variable. That's why we get dy. So I've just performed the power rule on y, and what happened was this all, we know y to the 0 is just 1, so that's why this just becomes dy. Now, if I continue taking the derivative, this 3 comes in front, so 4 times 3 is 12, x, and then I drop this by 1, and I get squared, and then I finish by saying the derivative of x. So here, if I want to get this in explicit form, we go ahead and divide the dx over, and we get dy dx is equal to 12x squared. Again, something that we just make a shortcut and we just say, listen, when you take the derivative of y, where y's to the power of 1, and it's by itself, this is called explicit form when y is solved for, and I take the derivative, the notation just goes to the derivative of y with respect to x is equal to whatever you came up with. All right, this information is going to help us today because we will be using a different variable, and therefore we have to show that we took the derivative of that variable, just like we did right here, and got dx. Okay, so if I ask you right now to find the derivative of y equals 3 times x squared plus 1 squared, right now, doing the power rule, this is in the correct form, and you know that you would have to expand it. And we would get y equals 3 x squared plus 1 times x squared plus 1. And then you would go ahead and double distribute, and you'd get x to the 4th plus x squared plus 1. And we would clean that up and get 3x to the 4th plus 2x squared plus 1. Still cleaning this up, getting 3x to the 4th plus 6x squared plus 3. Now, again, I haven't taken the derivative yet. I've just got it in the polynomial form so that I could go ahead and perform the power rule. And because this is an explicit form, y is solved by itself, I can just go straight from y to dy dx when I start to differentiate using the power rule. This becomes 12x to the 3rd power plus 12x, and then we know that the derivative of 3 is 0. All right, so this wasn't terrible because it was squared, but if this was raised to the 5th power, to the 6th power, I do not want to expand it 6 times, clean it up, and then take the derivative. There has to be another form, and there is. It's called the chain rule. The chain rule, so let me just cover some of this up. The chain rule is used to find the derivative of composite functions. And what do I mean by a composite function? you've seen in the past that I can have a function that's defined by two functions. If I put one function into another, this is considered a composite function. So here, looking at the problem that we just did, I saw y equals 3, and in red, I created this to be a second function, x squared plus 1. So off to the side, what you're seeing here is f of x is considered to be 3x squared, and g of x is equal to x squared plus 1. So this is a composite function as f of g of x, where g of x was the input of f. That shouldn't be new. So now I'm going to derive the chain rule, why it is the way it is, but I will tell you that there is an easier way at the end that I'll recap on. So if you get a little confused while I'm explaining it, just try to understand conceptually exactly what's going on. So if I looked at this and I want to do the power rule, I know it's not in the correct form. I want to avoid expanding. So when I avoid expanding, I'm going to do something that we call U substitution. Now, I'm always teaching you for the future, knowing what you're going to be required in AP Calc. And U substitution, although it's useful, is not necessary when we take the derivative. But eventually, we're going to be working backwards. We're going to be taking a derivative and trying to get to the original form. And that process is called integration, something that you'll learn later on in this year. And U substitution will be a must. So I don't want you to get to the end of the year and going, we never did U substitution, because we did. We'll see that it's not that necessary to apply every time taking the derivative, but will absolutely be necessary when we work backwards. Okay, so in the idea of U substitution, what I've decided, how we teach it, is we go ahead and make one of the functions be represented by U. In this case, I'm going to make g of x, which is x squared plus 1, be my U value. So I started to write this and decided I just would do it with you. Y equals 3, and instead of x squared plus 1, I'm going to write u squared. And now I look at this and I go, oh, this I could take the power rule on. And just as I said before, when we take the derivative and we finish by saying the derivative of that variable. So y just becomes dy. And then this just becomes, the 2 comes in front, multiplies, that becomes 6u, drop this by 1. And I'm almost done, except I have to say the derivative of u, because I just took the derivative of that variable. Well, we just said u was represented by x squared plus 1. So now if I want to know what the derivative of u is, that is going to be, take the power rule on this, 2x, correct? Dx, and the derivative of 1 is just 0. Okay, so now we're going to put this together without the u substitution. We're going to say dy is equal to 6. What was my u value? My u value was x squared plus 1. And then my du is 2x dx. And now to put it in the proper form, we know it should be dy dx, so I'm just dividing this dx over, and I'm getting 6x squared plus 1 times 2x. So this is what I have so far. And I'm questioning, is this the same answer as I just did in my last problem, where I got that the derivative was 12x cubed plus 12x? Well, let's see. Here, I can expand this and go ahead and distribute the 6x squared plus 6 and 2x, and then continue to distribute that, and I end up with 12x cubed plus 12x. And I see it's exactly the same thing, a lot easier. That is the chain rule. The chain rule is looking at it as two composite functions and seeing that what had happened was we took the derivative of what I consider the whole function, okay? So we're looking at this whole function and saying this 2 is coming in front. And then I just keep that x squared plus 1. And then last, I take the derivative of that inside. So, the chain rule. Taking the derivative of the outside, this became dy dx equals, the 2 came in front, 6x to the first. What was our inside function? Our inside function was the x squared plus 1, correct? So when we're looking at this step here is taking the derivative of the whole, meaning looking at just the outside function. We're not looking at what's in here. And yes, that was there. And the last step was to times it by the derivative of the inside. So now we look at this and I go, okay, what's the derivative of the inside? It's 2x. And you can leave your answer in this form. That is our chain rule. So last but not least, this is our notation for when we work with chain rule. You're given a function. Now, the one thing that I have to stress is A here must be a constant. Otherwise, you cannot use the chain rule. And what do I mean by a constant? I cannot have a variable here. This number out here can't be 3x or x squared. No variable can be here. If I have a function that can be looked at as a composite function, and this coefficient here is a constant, then I can do the chain rule. And the chain rule just says, we're taking the derivative, we're taking the power rule here, the n goes in front, I get an, and then I keep the inside. I don't touch the inside, and I drop that exponent by 1, and then I times it by the derivative of the inside. So in short, the chain rule is the derivative of the whole, meaning the outside, times the derivative of the inside. The next video you're going to see, you'll hear Miss Vavrika speaking because we decided that we're going to share making videos, and she's going to work through the examples that is your homework, okay? The odds, and you'll be doing the evens.